Okay, this is your notes on exponential growth and decay. Now remember, we're going to do this problem right here. So you're going to put this in your calculator, and then you're going to put this one in your calculator. Y equals 3 times 2 to the x. Okay, so we're going to put both of those in the calculator. What I want you to be able to do is when you put them in the calculator, this is the first one. Now notice whenever you put the parentheses in, uh, it kind of does this right here. That parenthesis goes away whenever you hit execute. So parenthesis goes away. That's okay. It still means the same thing. When you draw it, it should look something like this. Now notice as x decreases, y increases. As x goes to the right, y goes to the right, or goes actually closer to 0. So what I want you to get in the habit of doing is going from there to number 7, which is table. Put in the same equation, set. All right, let's go ahead and set it up. So I'm going to go, instead, I'm going to go from -3, and I'm going to go out to about, let's say, 5, and I'm going to count by 1/2. So if you notice, when you do your table, this is what you're going to put in your table. So notice you can't put these. You could try -212. You can also do 1.5, -1.6, -0.5. So you can actually put those numbers in your table. So if you look here on your table, the numbers I chose or happened to choose were -2, -1, 0, 1, 2, and 3. And that gave me 12, 6, 3, 1.5, 0.75, and 0.375. And you just kind of plot those numbers. So the first one at -212, I want you to notice you can't graph that on this graph, but you can estimate where it should be. So at -212 would be about right there. -1.6, 1, 2, 3, 4, 5, 6. So right here. 0, 3, that was your starting point. Notice it's on the y-intercept. 1, 1.5 is about right here. 2, I'm sorry, nope, that was wrong. 1, 1.5 is at 1, 1.5. And then at 2.75, 3, notice it just keeps getting closer and closer to the x-axis. And so when you graph it, make sure that it's a nice little graph. I'm going to try my best. Do not lift my pencil or my pen. All right. Notice it gets really close to that line. Put your arrows at the tips. Now, I want you to notice something. When we talk about domain, my domain, this graph is going forever and ever this way and forever and ever this way. So my domain happens to be -infinity to +infinity. My range in this case, now notice this is my starting point. So it's going to be at 0, and then it's going to continue going up. So that's going to go to infinity, and that's my range. Now remember, we also have an end behavior. We also have an end behavior. And as our end behavior looks at, that's this side over here and this here, okay? Those are my end behaviors. So as x approaches -infinity, y is going to approach +infinity. That's this one right here, okay? Now, on the other side, as x approaches +infinity, y is going to approach 0 because it gets closer and closer to 0 here. It just never touches 0. Okay? Now, this question here, what happens to the function or the y value as the value of x increases? Well, the y value decreases. All right? The y value decreases closer to 0. All right? Closer to 0. All right, now on this one, this is just the opposite of that. On this one, what I did, I used these numbers. So when I used it in the graph, -3, -2, -1, 0, 1.5, and 2. Well, I got 0.375, 0.75, 1.5, 3, about 8.5, and then 12. All right, so I'm going to go ahead and plot those points. All right, so at -3, 1, 2, 3, 3.75, So that's going to be approximately right there. Negative 2, approximately right there. Negative 1 is at 1.5. 0, 3. At 1.5 is 8.5. 1, 2, 3, 4, 5, 6, 7, 8.5. So about right there. And of course at 2, 10, 11, 12, which is about right there. So notice whenever you graph this, all right, it's a growth. So try your best to graph it as best you can. Okay. So now, what happens to the function, the y value, as the x value increases? Well, as x increases, in other words, as x increases this way, what's happening to the y value? Okay. And in this case, as x increases, the y value also increases. All right. So in this case, when we talk about our domain, again, from negative infinity to positive infinity, but when we talk about our range, again, our range is down here at 0. All right. So it's down here at 0. So our range is at 0, but it's going to go up to infinity. All right. And of course, you can do your end behavior as well. Now, on the back side of your worksheet, you had this. If the exponential function y equals a times b to the x, all right, so this, or in this function here, we're talking about this one right here. It says if b is between 0 and 1. Well, you know that if b is between 0 and 1, if you have 0 and you have 1 and b is in the middle, it's going to be a fraction, okay? It's either going to be a fraction or a decimal. So that indicates the y value, that's going to look like this on a graph, all right? So as x increases, the y value is going to decrease. All right, so the value of y decreases as the value of x increases, and the graph represents a model of exponential decay. On the flip side of that, if you look at if b is greater than 1, that means if b is greater than 1, anything number greater than 1 could be 2, 2.5, 3, so anything greater than 1. Well, the y value is going to the y value increases as the value of x increases, and therefore that represents growth, exponential growth. Okay? And then finally, classify these. Well, if you notice, remember, this is y equals a times b to the x. Well, let me highlight these for you. All right? So here is my b to the x. Notice there's a b to the x, there's a b to the x, there's a b to the x, and then there's b to the x. Notice I want to highlight the a in blue. There's nothing here. Well, let me get a little skinnier one. Let me do this one. Notice there's nothing there. There's nothing there. Well, the 8's there, so I can highlight that. And then, of course, the 4 is there. So, in this case, what is my a value? My a value is 1. If there's nothing there, it's always 1. Here, it's 8, and then here it's 4. My b value in this case happens to be 5, 0.4, 0.25, and 2.5. Now, it says classify each of the following models as either exponential growth or decay. So remember, if your b value is greater than 1, this is growth. All right? If it's greater than 1, this is growth. Therefore, if it's between 0 and 1, this is decay. Decay. All right, that's your notes for today's lesson.